Okay, today's notes is topic 2.13 part 2, exponential and logarithmic inverses and inequalities. So as previously we looked at inverse functions and finding the inverse of a given function, including exponential and logarithmic functions of the form y equals b to the x and y equals log base b of x. Now we will look at finding inverses of exponential and logarithmic functions in general form. So the general form of exponential and logarithmic functions are exponential is f of x equals a times b to the x plus h plus k. For our logarithmic function, f of x equals a times log base b of x plus h plus k. So we can find the inverse of y equals f of x by determining the inverse operations to reverse the mapping. So we have our 3 steps here for us, finding inverses. Step number 1, you're going to switch x and y. Step number 2, you're going to use inverse operations to solve for y. And then step number 3, we're going to write the final inverse function using the correct notation. So let's take a look at example number 1. So it wants us to find the inverse of the function. So first thing I want to point out to you is this. F of x is an exponential function. So if I'm going to find the inverse is going to be a logarithmic function. I know that because they are inverse functions of each other. So step number 1, I'm going to switch the roles of x and y. So f of x is the same thing as y. So when I'm going to switch x and y, 3 times 2 to the y plus 4 power minus 15. Okay, now in order to get the y by itself, the y is located with the base of 2. So I'm just going to highlight it so you can kind of see it a little easier. So the first thing that I want to do here is I want to get that highlighted part by itself. So there's 2 things that I need to do. I need to add the 15 to the left side of my equation. And the second thing I'm going to do is I'm going to divide everything by 3. And that's what's going to allow me to get my 2 to the y plus 4 power is equal to x plus 15 over 3. Okay, so right now I'm still in exponential form. So what I'm going to do next here is I'm going to convert it. And what I'm going to do is I'm going to convert it to its logarithmic form. Okay, so as I convert to log, the base is 2. So because the base is 2, that means it's log base 2. So I'll just color code it so you can kind of see it a little easier here. So the base 2 is right there. Your exponent, whatever you're raising it to the power of, that's what's on the other side of your logarithm. Because when you're taking log of something, that is the missing exponent. So that's the y plus 4. Okay, and then actually I need to make a little more space because it looks like it's going to take up some room here. So equals y plus 4, like that. Okay, and then again the final part of this piece here is going to go right here in blue. That's why I made more space for it. So I have the x plus 15 all over 3. Okay, so all I did was convert it. Now again, I'm still on step number 2. I need to solve for y. That means that I need to get this y value by itself. So in order to get the y value by itself, I'm going to subtract the 4. So I have log base 2 of x plus 15 over 3, close the parentheses, minus 4. Okay, so that would be step number 2. I was able to get the y value by itself. So now, last thing I'm going to do is I'm going to rewrite it using the correct notation. So f inverse. Okay, so the inverse function of x is log base 2 of x plus 15 over 3 minus 4. And this would be my answer. This is the inverse function. Okay, so what you'll notice here is, again, I had to switch x and y. I had to isolate the base of the exponent. I had to convert it into its logarithmic form. Then I could get the y value by itself. Okay, so let's take a look at number 2. Notice number 2 is a logarithmic function. So because number 2 is a logarithmic function, that means the inverse is going to be an exponential function. Okay, so I'll start off on the side over here. So step number 1, I am going to switch my x and my y. x equals negative 3 log base 5 of x minus 4 plus 6. So just like the last problem, the first thing I'm going to do is I'm going to use a highlighter and I'm going to identify, oops, I don't know why I put an X there. Let me get rid of that. This should be a Y. Okay, I am going to highlight the piece that I need to isolate first. So this is the piece that has my variable, my Y variable. So that's what I need to isolate first. So the way that I'm going to do it, I'm going to subtract the 6 to the other side. And then I'm going to divide by negative 3. Okay? Now, in most cases, you can just leave the negative 3 in the denominator. What you can also do is, again, I'm going to just skip a step. If I were to take the negative sign and move it to the numerator, that's the same thing. And if I distribute the negative sign, that's negative x plus 6, which is the same thing as 6 minus x. So I shift the negative sign to the numerator, and all that does is it changes the order of subtraction. So I have 6 minus x over 3 is equal to log base 5 of y minus 4. Now that I'm in logarithmic form, in order to bring that y value out, I'm going to convert to exponential form. Okay, so I am here. I'll color code it one more time. I'll match the same colors as last time. So I'm doing log base 5. That means this is 5. Whatever I'm equal to, that is my exponent. So that's going to go up here. So I have 5 to the 6 minus x over 3 power. And it's equal to there. So that would be my y minus 4. Okay, and so the last step to get the y by itself is just to add the 4 to the other side. So I have 5 to the 6 minus x over 3 power plus 4. Notice that I'm really trying to make sure you can tell the difference between exponent and constant that I'm being added to. So therefore, is this g? Okay, so this is g of x. So using the correct notation, g inverse. So 5 to the 6 minus x over 3 power plus 4. And this would be my inverse function. Okay. Last one for this page, let h of x is equal to 3 to the x plus 1 power minus 2, and k is h inverse. So the question is, for what value does k of x equal to 1? Okay, so if I want to figure out what k of x equal to 1 is, the first thing I'm going to do is I'm just going to find out what h of 1 is. So when I do h of 1, I get 3 to the 1 plus 1 power minus 2. So that's 3 squared, that's 9 minus 2. So that means that h of 1 is equal to 7. That means my input is 1, my output is 7. For k of x is h inverse. So therefore, if this is part of h of x, when you do the inverse, you switch the x and y's values. So for what input of x in h inverse gives you an output of 1, that means that k of 7 is how you get 1. So that would be my answer there. Okay, so that would be example numbers 1, 2, and 3. So let's turn the page and let's see how we do on the next side. So for part 2, solving inequalities involving logarithmic and exponential functions. So this one's a little tricky because we got to think about it in 2 parts. So it says previously we solved inequalities of polynomial and rational functions. To do this, we first found any x coordinates where the functions had zeros, wholes, and vertical asymptotes. Then we used the sign chart to determine intervals where the function was positive and negative. So we can solve inequalities involving exponential and logarithms in the same way, except it's much simpler when working with exponential and logarithms. Okay, so I have f of x, it's given to me, and it says what are the values of x for which f of x is greater than 0? So the first part that I'm going to do is I'm just going to solve the inequality. So to solve the inequality, I have log of x squared minus 4x plus 7 minus log of x plus 3, and it needs to be greater than 0. So all I did was I substituted in for f of x. Okay, quotient property tells me that I have log of x squared minus 4x plus 7 over x plus 3 is greater than 0. Okay, so what I'm going to do here is I have a base 10 log, and so because this is a base 10, what I'm going to do is I'm going to raise both sides of the inequality to the 10 to the power. Okay, so what happens here is 10 of log base 10 of this quantity. The 10 log base 10 cancel each other out. So I am left with this over x plus 3. And then 10 to the 0 power is just 1. Okay, I'm going to multiply the x plus 3 to the other side. When I distribute the 1, it's just the x plus 3. And when I subtract the x and I subtract the 3, I get that. I'll just clear it up a little. Plus 4 is greater than 0. So what you'll notice is, x squared. What you'll notice is this is factorable. So this factors into x minus 4 and x minus 1 is greater than 0. Okay, so you could use a sign chart, but if you just think about it graphically, here's 1, here's 4. This is a parabola that will open up. Okay, so because this is a parabola that opens up, all parts that are greater than 0 is to the left and right of my zeros, right? So if you think about it that way, when I do a real sign chart, there's 1, there's 4. This is where my graph is above, this is where my graph is above, and this is where my graph goes below. Okay, so as far as my answers are concerned, at this point right now, it's everything to the right of 4 and everything to the left of 1 at this point. Okay, so negative infinity to 1, and then 4 to infinity. Okay, now, just because we solved it doesn't mean that that's done. Now I have to consider domains of these logarithmic functions. Okay, so obviously the easy one that we need to think about is this. So if x plus 3 has to be greater than 0, my x values have to be greater than negative 3. So what you're seeing here is my answers are not just the red region, because now I'm going to have to start to cut into it. Okay. The second one that I need to consider is this quadratic logarithm on the left. So I'm just going to highlight it here. I'm going to pull out an old Algebra 2 skill. Okay. So keep in mind that for this problem, x squared minus 4x plus 7 has to also be greater than 0. Okay, so I'll just highlight, so that's where you know I'm getting this from right there. I'm going to use completing the square here. So completing the square, okay, I have a b value, which is negative 4. I'm going to half it, which is negative 2, and I'm going to square that, which makes positive 4. So what happens here is this. In order to make this a perfect square trinomial, that 4 needs to be there. Now notice that I originally had plus 7, so if I already used plus 4, there's still a plus 3 remaining. So all I did was I broke it apart. I took the 7 and I turned it into plus 4 plus 3. The reason why I do that is because this is a perfect square trinomial. This becomes x minus 2 quantity squared plus 3. The reason why I did that is because I know that this is a parabola. Its vertex is going to be located at 2, 3. And because my a value is 1, my graph opens up like that. Now, notice that the whole graph is above the x-axis. So what that means is y values are always positive. There is no restriction on the domain here. Okay, so the only restriction that I have, my warning, is here in blue, because the first logarithm that I highlighted yellow has no restrictions on the domain. No matter what, it'll always come out positive. Okay, so in this case, the only thing I need to account for is x is greater than -3. So now if I go back to this part here, all I need is x is greater than -3. So my answers have to be on this side here, like this. Okay? So therefore, what intervals are we looking at that overlap? So there's over here at 1, and notice that it was not including it. So there's an overlap. And then the second overlap is still over here. Okay, so the only thing my domain restricted was going towards -infinity. So now for my final answer, the overlap is from -3 to 1, and then from 4 to infinity. This is my answer here. Okay, so a little strange, but that's kind of what we're looking at as far as our answer goes. So you can solve it, and then you can restrict the domain, and then you have to find the overlap between your answer and your domain. Okay, for the second one, I'm going to use the same concept. Okay, this x plus 4 has to be greater than 0. So x is greater than -4. Okay, for the second one, x squared plus x minus 5 has to be greater than 0. So I'm just doing the domain at the moment. Okay, my b value is 1. When I half it, it's 1/2. And when I square it, it's 1/4. So what that means here is this: x squared plus x plus 1/4. So what number do I add with 1/4 to make -5? Because that's what I'm going to be doing to turn the 5 into two things. So in order to make it -5, I have to use -5 and 1/4. Because when I combine those two things in blue, they make -5. Okay? Now, by doing so, this perfect square trinomial factors into x plus 1/2. Okay? So what I notice here is this. -1/2, -5.5 is down here. My graph opens up. So what that means is I do have two x-intercepts, and it's only greater than 0 to the right and to the left of the zeros. So I'm going to actually have to solve this and try to figure out where those x-intercepts are. And the junk part is this is not going to work itself out nicely. So I'll just use quadratic formula. Or in fact, I can just use completing the square. So I have x plus 1/2 quantity squared, since I already did all this work. And then minus 11 over 2 equals 0. The 5.5, oh, I'm sorry. That was wrong. It's not 5.5, it's 5.25. Okay, 5.25. So that would be 21 over 4. Okay, so I add the 21/4 over to the other side. I take the plus or minus square root. And then I subtract the 1/2. Like that. Okay, so what this tells me is I have two x-intercepts. If I want to put it together, this is -1 plus or minus the square root of 21 over 2. If you do quadratic formula, you'll get the same answer. So what I'm guessing is for the addition, that's -1 plus the square root of 21 over 2. And this is the subtraction. This is -1 minus the square root of 21 over 2. So what that tells me is for the domain, this is all values less than this, and this is all values greater than this. Okay, so I have multiple restrictions there. Okay, now that I have that in place, I'm just going to solve. So g of x squared minus x, oh sorry, I forgot the natural log, natural log of x squared plus x minus 5 should be less than natural log of x plus 4. Okay? I'm going to get, because I have two logarithms, I'm going to get them on the same side. Natural log of x squared plus x minus 5 minus natural log of x plus 4 is less than 0. This is a quotient property. Natural log of x squared plus x minus 5 over x plus 4 is less than 0. Okay? I'm going to raise to the power of e. So e to this power is equal to e to this power. E to the natural log will cancel themselves out. I have x squared plus x minus 5 over x plus 4 is less than e to the 0 power. E to the 0 power is 1. So just like the last problem, I'm going to multiply the denominator to the other side. Okay. And then from there, I will subtract the x and then subtract the 4. X squared minus 9 is equal to 0. Okay, so again, this is x plus 3, x minus 3. And I want to know where it's less than 0, where it goes below the y-axis. So again, at negative 3 and positive 3, because this parabola opens upward, it's going to do that. And so therefore, my solutions, this is negative, this is positive, this is positive. My solutions are all within this piece right here. That's where my solutions are. So now it's just a matter of cutting the domain in. Okay, so what I have here is I need to be greater than negative 4. So notice that all of my answers are already greater than negative 4. So because all of my answers are already greater than negative 4, I'm not too concerned about that. Okay, the ones that I need to worry about is less than, so now I need decimals. Negative 1 plus the square root of 21 over 2, and I need negative 1 minus the square root of 21 over 2. So now I'm going to have to calculator. So grab a calculator real quick. And now that I have the calculator, I will get my decimals. I'm going to go 4 decimal spaces, just like AP Pre-Calc tells us to do. So when I divide by 2, this is 1.7912. Okay, and then negative 1 minus the square root of 21 divided by 2. So this is negative 2.7912. If you use 1.3, that's fine also. Okay, so I want to go to the right of this 1.7 blah blah blah, and I need to go to the left of negative 2.7 blah blah blah, like that. So what you'll notice here is, based on my red answer values, my domain starts to limit it between here and between here that I did in the purple. That's where my answers are going to be found. So therefore, my answers are between negative 3 and negative 2.7912 and 1.7912 to positive 3. So this would be your answer here. If you need to keep it in its radical form, you can as well. So you could do negative 3, negative 1 minus the square root of 21 over 2. And then from negative 1 plus the square root of 21 over 2 to positive 3. So that's the exact, and 1 is the rounded there. Okay, so again, a little bit tricky, can be done, you just are looking for the overlap. Okay, example 6, let k of x equal that. What are the values of x for which k of x is less than or equal to 31? So the only thing I'm going to do here is I'm going to substitute my function in, less than or equal to negative 31. Okay, once I'm here, I'm just going to isolate my base. So my base is here. This is what needs to be isolated. So the 1 goes and then the 4 goes, negative 4 goes. So I subtract 1, so I have negative 4 times 2 to the x minus 3, less than or equal to negative 32. Okay, I'm going to divide by negative 4. Don't forget that when you divide by negative 4, 2 to the x minus 3 power, I am going to turn my inequality around when you divide by a negative. Okay, you can either do log base 2 to both sides, or you can just convert it into its logarithmic form, whatever works best for you. So if I do log base 2 and log base 2, the x minus 3 will come down. Log base 2 of 8, okay, that's still the same thing as 3. So when I add the 3 to the other side, x is greater than or equal to 6. That would be my answer there. Okay, so that would be our second page. Let's turn the page and let's take for the last page. It says on the AP pre-calculus exam, FRQ will require students to solve various logarithmic and exponential functions without using a calculator. So below are a part of the directions that you will see on the free response problem, along with 2 sample questions that could appear on one of these FRQs. So the directions, you have to be able to do this without a calculator. So it says determine the exact value of any expression that can be obtained without a calculator. For example, log base 2 of 8 can be written as 3. Combine terms using algebraic methods and rules for exponents where applicable. So 2x plus 3x, 5 squared, 5 cubed, should be rewritten in equivalent forms. Okay, so taking a look at number 1, f of x is given. Solve for f of x equals e to the 1/2 power for value of x in the domain of f. So first of all, f of x is an exponential function. So that means that the domain is all real numbers. Okay, so I'm going to set e to the x to the 5th power over e to the 1/4 power is equal to e to the 1/2 power. I'm going to multiply both sides by the denominator. So I have e to the x to the 5th power is equal to e to the 1/2 times e to the 1/4. Okay, properties of exponents. I am allowed to add them together. So 1/2 plus 1/4 will give us 3/4. So I have e to the 5x, is equal to e to the 1/4 power. So now I just set 5x equals to 1/4. And then I multiply by 1 over 20 to the other side. Oh, not 1/4, 3/4. I'm sorry. 1/5. There we go. I got my numbers mixed up. So therefore, x equals 3 over 20. And that would be my answer there. Okay, so that would be the first one. For the second one, g of x equals 3e. So 8e to the 3x power minus e is equal to 3e. Okay, I want to get the base by itself, so I'm going to get this by itself right there. So I'm going to add e to the other side. So I have 8e to the 3x equals 4e. I'm going to divide everything by 8. So e to the 3x is equal to e over 2. In order to bring the x down, I'm going to use natural log because of the e. So I have natural log of e to the 3x is equal to natural log of e over 2. I'm going to bring the 3x down. Natural log of e is gone. I'm going to use the quotient property here. Quotient property says I have natural log of e minus natural log of 2. Okay. Last step is divide by 3. Also know that natural log of e is just 1. And the reason why natural log of e, the reason why natural log of e is equal to 1 is because e to the first power is equal to e. So this would be my answer here. Okay, so these are two problems that you should be able to do without a calculator. in preparation for an FRQ type of